Hello. Today I will be showing off Program 1 search methods. As you can see, we're on the preset data over here. We have the graph for dataset 1. Over here you see the controls for the search algorithms, the metrics, and over here we got the benchmarking button. It's automatically set to this, except I chose to be Gun Wichita. We start. Just gonna go quickly through the algorithms here. And down here you'll see all those metrics. You can see how it iterates. And from what I saw, the A star and the breadth first search had the smallest number of edges. Dataset 2, and I have it on the fastest speed. It can go slower. See how fast some of those go. But just for showing off, you can set the slow speed, and you can pause it and you can click step to step through each next step that the algorithm takes. And then you can do a randomly generated graph. This is preset here. You can set a seed here, and I can type in a new seed. That product owner. I have it separated in between 5 files. We got the main file here. This is very similar to how I'm doing it in my 449 project, uh, where I have a class for the visualization itself. Uh, in the visualization, it's using tkinter to make pretty much all the buttons, all the drop-down menus, all that, because that's very easy to do in tkinter. And it's using matplotlib for the graphs, because that's very easy to do in matplotlib is do the graphs. So using two uh, GUI packages. Got a node class to store its connections, its longitude, latitude, its position and such. And we have a graph class that makes the graphs and makes the random graphs as well. So making it all very easy to run. All right, let's go through all the algorithms. For breadth first search, pretty much all the algorithms are going to start with the frontier, which is usually the start node. For breadth first search, the frontier is going to end up acting like a first in, first out, which is like a queue, and that's really what makes the breadth first search algorithm work the way it does. And for all the algorithms where the yield is, this is what ends up really passing the visualization to the visualizer. For depth first search, the frontier ends up acting like a last in, first out, which is like a stack data structure. And that's how this one ends up dealing with the searching. Then we have the iterative, deepening depth first search. This one, similarly to the depth first search, it's basically just doing the depth first search multiple times, uh, setting a depth limit at the beginning that increases as it keeps going. And then we have the greedy best first search. The greedy best first search, uh, like the frontier ends up acting like a priority queue. Uh, so instead of like a regular queue, this time the queue has each of the nodes has a priority that it needs, and that's how it ends up going through the graph. It's considered greedy because it really looks at what is the best right now and doesn't consider the distance it has already traveled to get to the current node. And then we have the A star. The A star uh, is like the greedy method. The frontier is also a priority queue. The priority for each is calculated as cost so far plus heuristic for the A star though, which is different than the greedy.